An operating temperature is the temperature at which an electrical or mechanical device operates. The device will operate effectively within a specified temperature range which varies based on the device function and application context, and ranges from the minimum operating temperature to the maximum operating temperature. Outside this range of safe operating temperatures the device may fail. Aerospace and military-grade devices generally operate over a broader temperature range than industrial devices. Commercial-grade devices generally have the narrowest operating temperature range. It is one component of reliability engineering. Although biological systems do not have a defined operating temperature, individuals are most comfortable when body temperature fluctuations as a result of environmental factors are minimized. Ranges. Devices are manufactured in several grades. For example, the manufacturer Ultra defines 5 temperature grades for its products, each with an associated normal operating temperature range: commercial 0 degrees Celsius to 85 degrees Celsius, industrial, 40 degrees Celsius to 100 degrees Celsius, automotive, 40 degrees Celsius to 125 degrees Celsius, extended, 40 degrees Celsius to 125 degrees Celsius, military, 55 degrees Celsius to 125 degrees Celsius. These grades ensure that a device is suitable for its application, and may withstand the environmental conditions in which it is used. Normal operating temperature ranges are affected by several factors, such as the power dissipation of the device. These factors are used to define a threshold temperature of a device, that is its maximum normal operating temperature, and a maximum operating temperature beyond which the device will no longer function. Between these two temperatures, the device will operate at a non-peak level. For instance, a resistor may have a threshold temperature of 70 degrees Celsius and a maximum temperature of 155 degrees Celsius, between which it exhibits a thermal derating. For electrical devices, the operating temperature may be the junction temperature of the semiconductor in the device. The junction temperature is affected by the ambient temperature, and for integrated circuits, is given by the equation in which Tj is the junction temperature in a degree Celsius, Ta is the ambient temperature in a degree Celsius, Pd is the power dissipation of the integrated circuits in W, and Rja is the junction to ambient thermal resistance in a degree Celsius W. Aerospace and military, electrical and mechanical devices used in military and aerospace applications must endure greater environmental variability, including temperature range. In the United States Department of Defense has defined the United States military standard for all products used by the United States Armed Forces. A product's environmental design and test limits to the conditions that it will experience throughout its service life are specified in MILS TD 810, the Department of Defense Test Method Standard for Environmental Engineering Considerations and Laboratory Tests. The MILS TD 810G standard specifies that the operating temperature stabilization is attained when the temperature of the functioning part, S, of the test item considered to have the longest thermal lag is changing at a rate of no more than 2.0 degrees Celsius per hour. It also specifies procedures to assess the performance of materials to extreme temperature loads. Military engine turbine blades experience two significant deformation stresses during normal service: creep and thermal fatigue. Creep life of a material is highly dependent on operating temperature, and creep analysis is thus an important part of design validation. Some of the effects of creep and thermal fatigue may be mitigated by integrating cooling systems into the device's design, reducing the peak temperature experienced by the metal. In spacecraft propulsion, the performance of nuclear engines can be improved by raising the operating temperature of the fuel elements. Commercial and retail. Commercial and retail products are manufactured to less stringent requirements than those for military and aerospace applications. For example, microprocessors produced by Intel Corporation are manufactured to 3 grades: commercial, industrial and extended. Because some devices generate heat during operation, they may require thermal management to ensure they are within their specified operating temperature range. Specifically, that they are operating at or below the maximum operating temperature of the device. Cooling a microprocessor mounted in a typical commercial or retail configuration requires a heatsink properly mounted to the processor, and effective airflow through the system chassis. Systems are designed to protect the processor from unusual operating conditions, such as higher than normal ambient air temperatures or failure of a system thermal management component, though in a properly designed system, this feature should never become active. Cooling and other thermal management techniques may affect performance and noise level. Noise mitigation strategies may be required in residential applications to ensure that the noise level does not become uncomfortable. Battery service life and efficacy is affected by operating temperature. Efficacy is determined by comparing the service life achieved by the battery as a percentage of its service life achieved at 20 degrees Celsius versus temperature. Ohmic load and operating temperature often jointly determine a battery's discharge rate. Moreover, if the expected operating temperature for a primary battery deviates from the typical 10 degrees Celsius to 25 degrees Celsius range, then operating temperature will often have an influence on the type of battery selected for the application. Energy reclamation from partially depleted lithium sulfur dioxide battery has been shown to improve when appropriately increasing the battery operating temperature. Biology: mammals attempt to maintain a comfortable body temperature under various conditions by thermoregulation, part of mammalian homeostasis. The lowest normal temperature of a mammal, the basal body temperature, is achieved during sleep. In women, it is affected by ovulation, causing a biphasic pattern which may be used as a component of fertility awareness. In humans, the hypothalamus regulates metabolism, and hence the basal metabolic rate. Amongst its functions is the regulation of body temperature. The core body temperature is also one of the classic phase markers for measuring the timing of an individual's circadian rhythm. Changes to the normal human body temperature may result in discomfort. The most common form is a fever, a temporary elevation in the body's thermoregulatory set point by about 1–2 degrees Celsius. Hypothermia is an acute condition caused by the body absorbing more heat than it can dissipate, whereas hypothermia is a condition in which the core temperature drops below that required for normal metabolism and is caused by the body's inability to replenish the heat that is being lost to the environment. Notes. References